Hello! In this video I will be showing my first steps in Cyanotype printing, more commonly known as blueprinting. I have split this video up into 4 sections. Section 1, preparing the chemicals. Section 2, mix the solution and coat the paper. Section 3, expose the image. And Section 4, the development of the print. Section 1, preparing the chemicals. The things you will need include distilled water, ammonium ferric citrate, potassium ferricyanide, a beaker or measuring cylinder, 2 dropping bottles, and precision scales. Solution A is made by dissolving 2.5 grams of potassium ferricyanide into 25 milliliters of distilled water. First, we will measure out 2.5 grams of potassium ferricyanide. Then we dissolve the potassium ferricyanide into 25 milliliters of distilled water. Stir until completely dissolved. Use non-metallic tools. Metal may disturb the chemistry. Pour the solution into the dropping bottle labeled A. I am using quite precise measurements, but that's not strictly necessary. The process has some tolerance to error. Now it's time for the second solution, 7.5 grams of ammonium ferric citrate dissolved in 25 milliliters of distilled water. We will call this solution solution B. For me, it was easier to measure in 3 batches, 2 times a batch of 3 grams and 1.5 grams at the end. Add the ammonium ferric citrate to the distilled water and stir until completely dissolved. Pour the solution into the dropping bottle labeled B. In Section 2 we will be using the chemicals we made in Section 1 to coat the paper in photosensitive solution. The things we will need are a plastic container, a sponge brush, the solution we made in Section 1, and paper. You will need to experiment with the type of paper, as some papers are alkaline buffered and those work less well with the cyanotype process. I use paper meant for acrylic paint or watercolor paper. Watercolor paper gives me a good result. Mix equal parts of solution A and B together to make the photosensitizer. The resulting liquid is sensitive to mainly UV light, but also a bit of blue light. Therefore, the mixing of the sensitizer and the coating of the paper has to be done without the presence of daylight or other sources of UV rays. In my experience, 8 drops of both solutions is enough for 1 sheet of A4 paper. I usually coat the paper in batches. The ratio between the fluids is 1:1, but this is not critical. Mix the 2 solutions together. Gently coat the paper with the solution you have just prepared. Take care to not include dust or dirt. I use a sponge brush to do this. You can use your creativity here. You don't have to coat the paper evenly and you can leave brush strokes visible. Let the paper completely dry in a dark place. Section 3. Exposing your image. The things you will need are a flat surface, a pane of UV transparent glass, a source of UV light, this can be daylight, a fluorescent bulb or LEDs, a photo negative, I print a black and white negative on transparency film with a laser printer, and the sensitized paper. To expose our print, we place the photosensitized paper on a flat surface, place our negative, carefully align it, and cover it with cover glass. It is important that this cover glass is UV transparent and doesn't block UV light. I place weights on the glass to make sure that the negative contacts the photosensitized paper at all places. I have placed some UV activated tape on the background. That way I can see the UV rays are reaching the print. Now I turn on the light source. The exposure time depends on the light source. With the fluorescent tube I need an hour, but with the UV LEDs I later purchased, I only need 13 minutes. Daylight works as well. You will need to experiment with the exposure time to get a nice exposure. When obtaining the light source, make sure it's of the UVA or blacklight type. Exposure to UVB and UVC is much more dangerous and should be avoided. After 1 hour, shut off the UV source, remove the glass and the negative. You now have an exposed print. Time to develop. Section 4. Developing and rinsing the print. Get a suitable container that fits the paper so it can be fully submerged. We're gonna rinse the print with water. Ordinary tap water suffices here. I'm going to add a bit of acetic acid or vinegar. The vinegar neutralizes the slightly alkaline buffer in the paper. Be aware that using too much might change the color of the print. Gently insert the print into the water and agitate so that the excess chemicals are rinsed off. Keep agitating until nothing seems to come off anymore. After a while the water will become yellow and blue and it will be difficult to spot if the print is properly rinsed. Therefore we rinse another time with fresh tap water. When the water is completely clear and no chemicals come off anymore, take the print out and let it dry. I let the print dry on a nice and flat surface on a slight incline so that the water can drip off. You can also hang up the print to let it dry. If everything went well, you have just made a blueprint. There are many additional options for creativity, including toning, where you change the appearance of the color of the blueprint to another color. This is outside of the scope of this video. Thanks for watching and happy blueprinting.